Hey everyone, so today we're going to learn how to take the composition of functions. So just like adding and subtracting and multiplying and dividing functions, you can also do something called taking the composition of functions, which is denoted through this symbol right there. It's an open circle. Biggest thing is just to make sure not to get it confused with the multiplication sign. So f composed with g of x is defined to be f of g of x. So what's really happening here is you're taking this second function, g of x, and you are substituting it into f of x. Okay, so let's go right into an example. So let's say that I give f of x to be 1 over x plus 2, and I give g of x to be 4 over x minus 1. For this example, we are going to be finding f composed with g of x, and then we're also going to be finding the domain of the composite function. So in order to kind of just know what type of function you're working with and what values work and they don't, I first want us to find the domain of the original function. So before we start to find the domain of the composite, we need to first consider the domain of these original functions. So let's start off with f of x. So the domain of f of x in this situation, because our equation is a rational equation, remember that we need to exclude the values that will give us 0 in our denominator here. So here for this first one, our domain will be x such that x cannot equal -2. If I substitute a -2 into f of x, my function will no longer work, so I need to make sure that I exclude it from my domain. Now, g of x, on the other hand, it is also a rational equation, but in this situation, the value of x that will make this denominator 0 is actually a positive 1. So my domain of g of x is x such that x cannot equal positive 1. Now that we know the domain of our original functions, we can go ahead and start to find the composition function, the composite function. So f composed with g of x is again defined to be f of g of x. So what that means is in my function f, I am going to be substituting in g of x. So this would be f of, let's look back, g of x is defined to be 4 over x minus 1. So that is the expression that I will be substituting into f. Now I'm going to go ahead and copy down f, but wherever I see an x, I am going to substitute in my new expression. So this would be 1 over 4 over x minus 1 plus 2. Again, I took my f function, which is this one, and wherever I saw an x, I substitute in this expression instead. Okay? And then from here, you just use your knowledge of kind of simplifying down a very complex fraction to get your simplified composite function. So I can turn that 2 to 2 over 1. I can use my triangle method to get a common denominator, and then I can use my in and out method to simplify down my complex fraction. So that top one, I'm just going to copy it over that denominator. I can simplify it down. 4 times 1 gives me 4. Positive 2 times x minus 1. Make sure you distribute out to the entire binomial. This would give you plus 2x minus 2 all over, and then you multiply across. X minus 1 times 1 is just x minus 1. I can simplify this down a little bit more. I have some like terms right here and right here that can be combined, and I can rewrite the numerator as a fraction. So this would be 1 over 1 all over 2x plus 2 over x minus 1. This is now a complex fraction, which I can use my out-in method, multiply these outer ones and these inner ones together to simplify. So 1 times x minus 1 gives you x minus 1 over 1 times 2x plus 2 just gives you 2x plus 2. My last simplification here is in that denominator. You can factor out a 2 to leave you with this fully simplified composite function. So f composed with g of x simplifies down to x minus 1 over 2 times x plus 1. So now that we have our composite function, we are asked to find the domain of it. And the way that I like to remember the domain of the composite function is, so again, this is now my domain, is first things first, you need to exclude the values of the function that you inputted. So in this situation, I took g of x and I inputted it into f of x. So I for sure need to exclude the values from g of x. Now, g of x was this expression here, and the value that had to be excluded in that original function was positive 1. So I am going to have to, in my composite, it's going to be x such that x cannot equal positive 1. So that comes from g of x. That comes from the function that you substituted into the other function. Now, once you, the domain of f of x in this situation, it doesn't really matter because you are altering the f of x function. You're changing it. So that one kind of the domain of the front part of the composition, that one doesn't matter. The only one that you need to consider from the originals is the second function, the function that you are actually inputting into the function. So we for sure need to exclude 1. And then the other part of this domain is now we have to actually consider our new composite function, which is this one right here. And the values here that have to be excluded are the values that are going to give me 0 there. So x plus 1 cannot equal 0. So you just subtract 1 to both sides. So you end up getting x cannot equal negative 1. So from our resulting composite function, our domain has to exclude negative 1. So this would be our domain of our composite function. So as a little note here, remember to identify this domain, you exclude values from g of x and f composed with g. That's it. Okay, so although I did have us identify the domain of f of x, we actually don't need it to determine our composite domain. That was more just to know in general f of x what values had to be excluded, just because it's good to be aware of domains of functions as you're working with them. But yeah, to actually determine the composite one, you just use g of x, which is the function that you're actually using to substitute into the other function, and then the new composite function, just considering the domain from there. All right, this is how you identify the composite function from two functions and the domain.